Okay, continuing on with the particles. Let me get share screen going here. So I left off, we talked about the main module and some of its options. And I mentioned that any new particle system automatically comes to life with an emission. It doesn't come to life with a force, but it comes to life with an emission, a shape, and a renderer. We're going to add a lot more modules. The emission module, and incidentally, this is a link to the web page for the emission module, controls the rate that particles are being emitted. It has two different settings. One is rate over time. So this constant value is going to emit 10 particles per second. Whereas if I had a number in this second slot, it would emit particles at a rate per distance. If I had a 10 in there, it would emit 10 particles per meter that the object moved. We also have bursts, of which we can add as many as we want. With bursts, we have a time at which the burst occurs. We have a count, which is how many particles are emitted in that burst. We have a cycle, which is how many times it repeats the burst. And we have the interval between those cycles of bursts. And we have the probability that such a burst will be emitted. These are the kind of standard options of our emission module. Now, I already showed you the 1,000 over time, but if I set this back to 0 and I set this to 10, and now I move my particle system around, as I'm moving it, it's emitting particles. There's a case where you can see the world space was local. As I moved the thing, the particles stayed with the object. If the simulation space is world and I move the object, it leaves them behind kind of as a trail. So these are all very, very cool. So that's emission. Oh, and the burst, if I were to specify a burst, let me set that to 0, add a burst of 30 at time 0. And now if I run this, I should, well, I got to put it somewhere I can see it. I put it somewhere I can see it. If I run this, it should just make a burst of particles. I don't know why it didn't. Because my lifetime is too short. Close enough so that I can see the thing. Oh, didn't last long enough to see. So that's the emission module. Now the shape module is what shape are the particles emitted from? And we have a number of different choices here. Shapes include the sphere, the hemisphere, a donut, a cone, a box, a mesh, maybe lerps, a circle, a rectangle, an edge, and there's some more, and they each have their own set of definable parameters. For instance, a sphere has a radius, whereas a cone has a radius, that's the radius of the base of the cone, and then the angle that the cone opens. Here are some of the settings for the cone. It emits from the base or the body. We have the angle of the cone, the radius thickness. This radius thickness determines whether it comes out of the surface of the cone, whether it comes out of the base, or whether it comes out of the volume. And you can segregate the cone into an arc, so only a portion of the cone emits the particles. Let me go back here and delete it and make a new one. So this one is emitting in a cone. I believe we can see the shape of the cone. This shows us a gizmo that lets us see the shape of the cone. These are being emitted from the base, emit from base. If we emit from the volume, then they're coming out all through the volume of the cone. If I make the base smaller, it's kind of coming out of and emit out of the base, then we're kind of being emitted from a point. We can set the thickness of our radius, whether it comes from the edge of the base or from the area of the base. And we have various settings to kind of offset the position, rotation, and scale of our emitter from the position and rotation and scale of the transform. A sphere emits from, in this case, well, the sphere has a radius of 0, so it's not a very big sphere. Make it a sphere of radius 1. And now we're being emitted from inside that sphere. If I make that 10, now we're being emitted from inside that sphere. Let me turn the velocity down to 0 so that the particles all kind of stay where they're born. Start speed of 0, and I'll restart it. So now you can see the particles are being emitted in that sphere. The hemisphere is just exactly what it says. It's a half sphere. So make it a little bigger. There's the hemisphere. A cone we've already seen. The donut has a radius and the donut radius. So here's our donut. And again, particles are being emitted inside that sphere. Here's that arc thing that lets us specify a portion of our donut, and this applies the same way to the sphere, the hemisphere, and the cone. We can emit from only a portion of its spread. There's also a box. Somewhere here we have to specify the size of our box. 5, 5, 5. Make it 10, 10, 10, 10. And so now we're emitting from the box. And we have meshes. If I had a mesh, I could emit from the vertices of a mesh. from a mesh renderer, from a skinned mesh, from a sprite, from a circle, um, circle radius 10. There's our circle, an edge. This is a line that it emits from, and a rectangle, which is kind of like our box. So there's our rectangle. So the shape module lets us define the place in the world from which the particles are emitted. We have let me go back to one of the more traditional shapes here, the sphere. I'll make it a little smaller and kind of get up close to it. So with the velocity set to 0, these particles are just appearing, living out their lifetime. They have a 5-second lifetime. If I give them a speed of 2, well, 10, they're now being radiated from the sphere. This is one of the settings that we have in the shape, whether they are aligned to the direction of the object, whether they're random in direction, whether we've made them spherical, or if we are randomizing the direction. So all of these settings affect the speed that the velocity that the particles will come out with, the velocity vector that they'll come out with. I'll add a module here, velocity over lifetime. This lets us set how fast the particle goes over lifetime. And of course, with constants, it's just going to stay that value the whole lifetime. But we can put curves in there that make it behave in particular ways. So with this particle system, I'll add a velocity over lifetime. There's velocity over lifetime. Whoops, that's the wrong one. Velocity over lifetime. And I'll pick here curves, and I'll define each of the different curves. I'll have that one go up. I'll have this one go down. And I'll make this one go up. So my x velocity is a constant 1. My y velocity increases up to 1 from 0. This one decreases from 1 down to 0 over the lifetime of my particles. Let me set all of these to 10 so that particles do something fast. Set that up to 10 as well. So now my particles should be behaving according to those. Let's set the start speed to 0 so that we can actually see what they're doing. This particle system, they're moving off in the x direction at a constant rate, but over time they're doing different things in the Z and Y direction. You can specify the space, whether the axes depend on local or world space. There's an orbital velocity that'll rotate them around the origin. We can offset the position about which they orbit, and we can also set a radial velocity that will move either away from or towards the center position of my object. So you can pretty much control the velocity of your particles over time. There's one really interesting one called noise. Let me turn off these velocity over lifetime here. Turn that off. And I'll make it emit a whole bunch more, 100. And I'll give it an initial upwards velocity of 5. And I think I want to make this a cone so that they're kind of shooting up in the air with a small base and a kind of wide angle. And I need to give them a longer lifetime, 10. So, and let me add a gravity to, no, 0.25, no, 0.1, 0.1. Okay, so here we have a nice little fountain effect. Let me increase their lifetime here to 100 so that they last a real long time. Over in this little trick, we can restart these things, which shows us how many particles there are and what their speed range is as they're going. And I can change the playback feed, so I can make it play faster. And there I filled it up. I ended up with 1,000 particles, and it ran out of particles. So I can restart this, set the playback speed to fast so that it fills up pretty quickly. And my particles are falling down there. And they're getting up to 30 some meters per second before they disappear. So the next module I want to add is the, I think is the noise. Right, I want to add the noise. So if I add a noise module, immediately you can see that these things are not following such deterministic pathways. 0.01. They're not following such deterministic pathways. Now there's a bunch of wiggling as they go through their paths. The noise, we can specify noise in separate axes. We can specify its strength, the frequency, how many octaves we're going to use. 1 octave means that it just selects from this noise picture. This is called Perlin noise. If I have more than 1 octave, now I have 2 of these superimposed on each other. So we now have a higher frequency noise superimposed on the lower frequency noise. And you can play with this and see the different kinds of noise that you get. But it's a good way to add kind of flickering effects to our particle systems. Separate axes, strength, frequency, scroll speed, how fast it moves through this little noise world. So the noise pattern that it's selecting its values from is changing as it scrolls through our Perlin noise. Limit velocity over lifetime is going to stop our particles from falling too fast. You remember over here with the higher gravity value, with the 0.1 gravity value, the particles got up to a relatively high velocity. If I add that limit velocity over lifetime module, turn off the noise, and I limit their speed to 10 and set a drag value of 1, the particles are now going to, I shouldn't have multiplied by size, check. My particles now with too much drag, they don't slow down as much, 0.1, a little bit of drag. The dampening is how quickly they go back to their limit speed. If I set this to 0, now the particles are only getting to 10, and then they're no longer accelerating. With dampening of 0, of course, they then go back to their fast 90 meters per second down at the bottom of this fall. Inherent velocity. If we have a moving object, a particle system that's moving, and let me make the simulation space world, so that with this particle system moving, the particles are left behind. With the inherent velocity, I can specify with the inherent velocity I can inherit some fraction of the object's velocity, say 0.5. So now a moving object, the particles are getting some of the velocity. They're inheriting the velocity of my moving object. So that's the velocity. I'll pick up with force and some of the other modules. I want to keep these lectures kind of short. And so I'm going to stop sharing here. And I'm going to stop recording, and I'll come back in and pick up with more of the modules in the next segment. Stopping recording. I'll see you in class. Bye.